Hello friends, today the topic name is force. The subject is physics on the 10th class icse syllabus. Uh, okay, let's get started. First of all, what is meant by force? Force is an external cause which tends to change the state of rest or motion. It is an external cause to change the state of rest or motion. Force is used to change the state of rest or motion. If you kick the ball, it first of all, in the first ball is in the rest. If you kick the ball, it will go into motion. You applied force on it. Do you get it? Okay, motion. When the football is coming, you try to stop it. You are applying force to stop it. It is also an external cause, like this. Next, effects of force on non-rigid body and rigid body. Let's see. On non-rigid body, it changes size and shape of the body. On rigid body, it brings the body into motion. Okay, it brings the body into motion. First of all, on non-rigid body, it changes size and shape of a body. In the next page, there will be an example. First of all, I will explain. On rigid body, there is no change of size and shape. If you push the wall, you apply force. There is no change in the wall. There is no displacement. There is no motion. Okay, and there is no change of size and shape of a body. In rigid body, there are two types: pivoted and non-pivoted body. Pivoted body means, what is meant by pivoted body? It means it is fixed at a point. It is fixed at a point. Do you get it? Non-pivoted body means it is not fixed at a point. It is not fixed at a point. See, there are two types of in rigid body. There are two types: pivoted and non-pivoted. Pivoted means it is fixed at a point. Non-pivoted means it is not fixed at a point. Same. If the body is pivoted, it possesses rotatory motion. It means circular motion. Okay. If the body is non-pivoted, it possesses linear motion, straight forward. Next, for example, on non-rigid body, it changes the size and shape of a body. Yes, you can see. In the stress ball, first normal, it is normal. After applying force, there is a change of size and shape. You can see there. On non-rigid body, on the wall, there is a action, but the reaction also there. The reaction, in the first example, the reaction is less. In the second example, it is rigid body. It is very strong. Wall is strongly built. Yes. Next, moment of force. Moment of force is equals to force into perpendicular distance from the axis. Do you get it? Moment of force means force. How much force you applied into perpendicular distance from the axis. What is meant by axis means pivoted point. What is meant by pivoted body? It is fixed at a point. That point is known as axis. Okay, perpendicular distance from the axis. The distance from the pivoted point to the end of the object. Force into okay. Next, anti-clockwise movement. Anti-clockwise movement, you can take as ACW movement, is taken positive, and clockwise movement is taken as negative. These two are main. negative and positive. Unit of moment of force is equals to force into perpendicular distance from the axis. The unit of force is Newton and the distance is meter. The moment of force is equals to Newton into meter. Do you get it? It is a vector quantity. Okay, it is a vector quantity. Next, okay, you can see here it the downward force. This is anti-clockwise and this is clockwise. Do you get it? Anti-clockwise and clockwise. This moment is taken as positive and this moment is taken as negative. Okay. Next, cases of moments of force. What are the cases? Let's see. If the magnitude of the force is equal to 0, magnitude of force means force applied on a body is equal to 0, moment of force is equal to 0. It is very easy to understand. Magnitude of force is equal to 0. When the force is equal to 0, moment of force is equal to 0. Moment of force means displacement. Okay, displacement. There is no no force, there is no displacement, there is no moment of force. The perpendicular distance from the pivoted point is equal to 0. The perpendicular distance from the pivoted point is equal to 0. Moment of force is equal to 0. It is very easy to understand. I will let you know. What is the formula for moment of force? The moment of force formula is force into perpendicular distance from the axis. When the force is equal to 0, 0 into anything, 0. Moment of force is equal to 0. When the perpendicular distance is 0, force be anything, 5 newtons, 5000 newtons, 5 lakhs newtons, 5 crores newtons. Moment of force is equal to 0. Okay. If the force is applied on axis of rotation, if the force is applied on axis of rotation, the moment of force is equal to 0. This is very important. I will let you know. Yes. Okay, first of all, for the first case, example, force is applied on the block is equal to 0. When the force is 0, there is no displacement. When you apply force, then it is the displacement, it will get to here. There is no force, there is no displacement. This is the case, this is the case 1. And the next, perpendicular distance from the pivoted point is 0. Means here in the door, it is pivoted out 3 points. Yes, this is the perpendicular distance. If you try to push here or pull here, it will easily open or close. It will open the door, or it will there is a moment of force. If you apply force on the axis pivoted point in the door where it is fixed, there is any displacement. If you apply much force, you can try and you can call 10 members to pull or push it, but there is no displacement because the perpendicular distance is 0. When you put force on here, there is a displacement, but it is little hard. If you apply force on handle, it is very easy. Okay, this is the meaning of the perpendicular distance from the pivoted point is equal to 0. Next, force is applied on axis of rotation. Axis of rotation, you can see here the boy is putting force on axis of rotation, means here. he is putting on the force. It is straight forward to the axis of rotation. And if you apply force on here, there is a change. On back side here, there is a change. If you straightforwardly apply on the axis of rotation, it is the axis of rotation where it can rotate. There is no moment of force. There is no displacement. It is very hard to move also. Okay. Next one. Principle of moments. What is meant by principle of moments means sum of clockwise and anti-clockwise moments is equals to 0. It is very main. They will definitely ask in the board exam. No. I'm sorry. There is a chance to ask the question, but this is very important. Sum of clockwise and anti-clockwise moments. If these are clockwise moments minus 5, the anti-clockwise moments plus 5 is equals to how much? 0. Yes, minus 5 plus 5 is equals to 0. The sum of clockwise and anti-clockwise moments is equals to 0. Do you get it? This is the principle of moments. And next, equilibrium. Equilibrium. See, when a number of forces acting on a body produce no change in its state of rest or state of linear motion or rotational motion, body is said to be in equilibrium. Okay, see here. If the body is in the rest, number of forces means, okay, if you take here a wall, here there is a person, person A will apply the force here, person B will apply the force here, C and D and E and more. What a number of forces acting on a body. It is a wall. Number of people are applying force on different points, but the no change of rest. It is at the rest position. There is no motion. They didn't bring the wall to motion. Then it is said as rest. Equilibrium. Number of forces acting. There is no change in rest. It is in the rest. If you apply force, it has to change the position. It means displacement, but there is no displacement. It is said to be equilibrium. Next, for example, for the motion, for example, if you take a ball, it is a big weighted. It has mass 50 kgs. It is rolling towards you. If you try to stop, what will happen? It will roll on you. You cannot stop. You can stop. If you take 100 kgs and it is coming very fast, you cannot stop. You have applied number of forces. You have tried many. You have tried that, but there is no change of state. It is in motion. It doesn't move to the state of rest. So it is said to be equilibrium. Okay. Next, here you can observe here. There is a force. But there is no change of state. So it is known as equilibrium. Easy. Okay. Next, center of gravity. See, it is the point through which the entire weight of a body acts or it is placed. It is the point through which the entire weight of a body acts or it is placed. It is a point. Okay, let us take an example. This is a circle. Here it is a point. The entire mass of the circle, it is placed at center. It is the entire weight of the body is acting on this point. Then it is known as center of gravity for this circle. Okay, next. Note the position of the center of gravity of a body of a given mass depends upon its shape. This is important. The position of the center of gravity. The position of the center of gravity where the weight of a body acts. Given mass, it is depends upon its shape. Very important. For a different shape, for a different object, there is a different center of gravity. Okay, there is an example for you. See, for this one, it is a center of gravity. For this line, for this rod, there it is a center of gravity. For this rod, it is a center of gravity. For this circle, it is center of gravity. For this triangle, G is a center of gravity, and for F diagram, G is the center of gravity. For rhombus, circle, cone, cube, these all, here is the center of gravity. For different shapes, for different objects, there is a different position of center of gravity. Do you get it? And if you like this video, please subscribe to my channel. Thank you for watching this video. Thank you.